Now we need to calculate the trim of the example boat. Just like the displacement and draft and buoyancy sections, the trim of the boat is only affected by the buoyant parts of the boat. Therefore, the weights inside do not matter, nor does the steering assembly mount. My first equation is my moment to trim 1 inch. This is equal to my displacement from my waterplane areas times my metacentric height longitudinally, of course because we're talking about trim, we're talking about the longitudinal, divided by my length at waterline. My boat displaces 366 pounds. My metacentric height was 74 inches. And my length at waterline is 73 1/8 inch. Therefore, my moment to trim 1 inch is 373.07 inch-pounds per inch. Even though the units include inches in both the numerator and the denominator, I retain them for the sake of understanding. Since my boat trims about the longitudinal center of flotation, it can be deduced that it takes 373 pounds 1 inch away from the center of flotation in order to increase the trim by 1 inch. Likewise, I can place half that load, 187 pounds, 2 inches away from my longitudinal center of flotation in order to increase my trim by 1 inch. Easier yet, I can place 37.3 pounds, 10 inches away from my LCF in order to increase my trim by 1 inch. My next equation is to find my actual amount of trim. This is equal to my displacement times my longitudinal center of buoyancy minus my longitudinal center of gravity divided by my moment to trim 1 inch. Therefore, my trim comes out to be a negative number at negative 6.61 inches. I find that my trim is a negative number, which means that my boat trims by the stern. This makes sense when evaluating the design. My boat has a lot of weight in the stern without a significant amount of buoyancy to counteract it. It can also be seen in the trim equation. My center of buoyancy is 44.31 inches away from the reference point, and it provides an upwards force, where my center of gravity is even farther aft at 51.04 inches, and therefore this couple rotates the boat so that it is trimming by the stern. My trim of 6.61 inches is pretty significant. This is a problem that would cause a redesign because all of my previous calculations assume that my boat is vertical and level. However, since my boat has trim, my larger stern section is more in the water than my sloped bow. This throws off calculations like waterplane and station areas, which in turn throws off additional calculations that feed even more calculations. For instance, I have a water line, and I have done all my previous calculations assuming that my boat is level, like this. And so when I took a station area, say right here, the station area was actually incorrect because my boat's actually trimming by the stern. So if I can show this, this is very exaggerated, but my boat is trimming by the stern, and the station area that I was calculating to be level is actually more like this. Let's say that my trim is acceptable and continue on with the calculations. The lowercase letter f is the distance between my draft at the bow and the draft at which the boat would float if level. It is not my draft at the bow. Since the boat trims about the center of flotation, the equation uses the ratio between the longitudinal center of flotation and the length at the waterline. I then multiply this by my absolute value of my trim. My longitudinal center of flotation is 42.5625 inches, where my length at the waterline, of course only of my buoyant hull, is 73 1/8 inch, times my trim, which was negative 6.61, but I'm only using the positive value, and I get 3.85 inches. To find my draft at the bow, I take my mean draft, which I found to be 6 inches from my waterplane area displacement calculations, and I'm going to subtract the lowercase letter f from that. The reason that I'm subtracting the lowercase letter f as opposed to adding it is because I know that my bow is riding high out of the water, and therefore my draft of 6 inches shouldn't really be 6 inches, but less than that, at only 2.15 inches. The lowercase letter a is the difference between my draft at the stern and the draft at which the boat would float if level. My equation is my absolute value of my trim minus my lowercase f, and that's because 3.85 inches of my trim of 6.61 inches is taken up at the forward part of the bow, so I need to find out how much is remaining for the aft portion of my hull. To find my draft aft, I'm going to add my mean draft and my lowercase letter a, because I know that my draft aft is supposed to be greater than it would be if my boat was sitting level. And therefore my draft is 8.76 inches at the stern. The depth of my hull is 12 inches. Therefore my freeboard at my bow is 12 inches minus the draft at my bow, which is very low at 2.15 inches, is 9.85 inches. And therefore my freeboard at my stern is the depth of my hull, 12 inches, minus my draft at my stern of 8.76 inches. And my freeboard is 3.24 inches. Here I find that since my boat is trimming by the stern, I have only 3 1/4 inches of freeboard at the stern. This is worrisome because it's a violation of the guidelines. What's worse, this is 3 1/4 inches at the aft perpendicular of the hull, which doesn't include the steering box mount. This means my steering box mount and my electronic steering box is even closer to the water than 3.24 inches. I could try to add my second sandbag to the bow to try and eliminate my trim, but then my weight and therefore my mean draft would increase, and I would violate the freeboard requirement even if I had no trim, since the depth of my hull is only 12 inches and my mean draft is already 6 inches. Ultimately, I would be operating in an illegal and heavy boat with a slightly better trim. Besides, I already know from my moment to trim 1 inch equation that I cannot correct that much trim. Therefore, the boat requires a redesign in order to become a finalist.